Okay, so here we've got a simple representation of an atom. Pause the video here and see if you can label these parts of the atom. Also tell me what the element is and then work out what you can fill in these gaps with here. So we have a nucleus in the centre of the atom, and the nucleus is made up of neutrons and protons. And as you'll notice, I realised that this was labelled wrongly. Can you spot how I knew it? The reason is because this has 6 electrons in it, which means that it must also have 6 protons if it's a neutral atom. There are 6 of these green circles and 7 of the red circles. So the green circles must be the protons. In a neutral atom we have the same number of protons and electrons. So we have protons and neutrons in the centre of the atom, which makes up our nucleus. Around the outside in energy levels or shells we have electrons. Remember, this is just a model to represent what goes on inside an atom, but it's sufficient for GCSE for where we are at the moment. In the first shell you can have up to 2 electrons. In the second shell you could have up to 8 electrons, but actually because this element has only got 6 electrons, we've only got 4 in this shell here. That could all electrons, depending how many you needed it to hold to use up all of the electrons in the atom, or to hold all the electrons in the atom. Now protons have a relative mass of 1. Neutrons also have a relative mass of 1. An electron is almost negligible in mass, has a mass of almost 0 compared to proton and neutrons. Now protons are positively charged, neutrons are neutral, they have a charge of 0. Electrons are negatively charged, they have a charge of -1. Atoms are really small, they have a radius of about 0.1 nanometers. The nucleus in the centre of the atom is absolutely tiny compared to the size of an atom as a whole. In fact, the majority of atoms, so therefore the majority of everything in the universe, is actually empty space. The radius of a nucleus is about a 10,000th of that of an atom. So when we looked at the periodic table, we said that the elements are gathered in order of their atomic number, which is the number of protons. So this number here tells us how many protons an atom contains. So for example, boron would contain 5 protons, carbon would contain 6 protons, thallium would contain 81 protons. It doesn't matter what the atom is, if you have the periodic table it will tell you the number of protons within it. If the atom is neutral, if it's a neutral atom, this will also tell you the number of electrons within an atom. So if you have cobalt atoms, they will have 27 protons and then they'll also have 27 electrons. So they've got 27 positive charges and 27 negative charges. They cancel each other out and overall we have a neutral atom. So carbon, for example, has an atomic number of 6, so it has 6 protons in it. Now carbon has 2 isotopes. One of these isotopes has a relative mass of 12 and the other one has a relative mass of 13. Now you'll remember that the particles that give the atom its mass are the protons and neutrons, not the electrons. So therefore this must be telling us something about the number of neutrons. It can only be the neutrons that are having an effect on the mass. This number tells us the number of protons, this number tells us the number of protons plus neutrons. So here if we've got 6 protons we must have 6 neutrons as well. Here we've got 6 protons, but overall our mass is 13, so we must have 7 neutrons. 6 plus 7 is 13.